In this last example, we noticed that even though the function, the integrand 1 over x squared plus 1, is continuous over all real numbers, since the denominator is always going to be positive, but we notice here that we've got two endpoints of integration which are improper. Okay, so we've got negative infinity down here all the way to positive infinity, and we're trying to compute this integral if possible. So to deal with both of these improper endpoints of integration, we break the range of integration into subintervals in which at most one endpoint is improper. So we look at the following but taken provisionally. Okay, provisionally meaning that we're not really sure if this is going to work, but this is our best shot. Okay, so we just pick a random number. We don't really need to pick any real number over another one, other than if we pick 0, it would be the most likely candidate. It would be the easiest, because 0 being an endpoint of integration makes it a little bit easier to deal with. So like I said, we could pick any real number from negative infinity all the way to infinity to break our integral up into, and I'm going to choose, in this case, I'm going to choose 0. So this integral from negative infinity to positive infinity is equal to the integral from negative infinity to 0 plus the integral from 0 to infinity. So again, we want at most one endpoint of integration to be improper. Okay, so this will give us a good idea of what to do when the bottom endpoint, or the lower endpoint of integration, is infinite. And so we're going to take the limit, and we're going to send a towards negative infinity. Okay, so again, we're just going to let a be, if you look at the picture, we're going to let a be somewhere over here to the left of 0. And we're going to send a all the way out to negative infinity. Okay, we're going to first evaluate the integral from a to 0, and then we're going to see what happens with this integral when a goes to negative infinity. Okay, so that's the idea, and we again just replace the negative infinity with a and send a to negative infinity, and then over here, just like we've done before, we're going to let b approach positive infinity, and we're going to evaluate the integral from 0 to b of 1 over x squared plus 1 dx. Great problem, because it reminds us that what our integral formulas are, and if you think through how do we find an antiderivative for this? Well, we look at it's either a formula, it's u sub, it's parts, or it's partial fractions. Okay, so it's one of those, and the first one we come to, we should recognize this right away if we write it as let me see where I could write this off to the side here. The integral of 1 over 1 plus x squared dx is inverse tangent of x plus c. Okay, so 1 over 1 plus x squared, the integral, the antiderivative of that is inverse tangent of x. So this is why you'll see why I wanted you to be able to know what the shape of the graph of inverse tangent looked like. So this is finally where we get to see this. All right, well, since we do have a formula here for this, we can just easily replace this integral with inverse tangent of x, and we're going to evaluate that from a to 0, and we're going to add to that, again, limit. Make sure you keep writing that limit. I know you're not going to, everything in you is going to try to fight that, but just keep writing that. It helps your understanding of what we're doing here. The limit as b approaches infinity of inverse tangent. Good thing is, once you find one, you've got the other, from 0 to b. Okay, well, we have to first evaluate the definite integral from a to 0, and the inverse tangent of 0, this is really going to test you because you really need to know your inverse functions here, minus the inverse tangent of a, okay, plus the limit as b approaches infinity of the inverse tangent of b, okay, minus the inverse tangent of 0. Okay, well, now we're able to find the limits as, well, we already know that the inverse tangent of 0 is 0 because the tangent of 0 is 0. So that goes to 0. Okay. Let me do this. Let me just send whatever's going to go to 0. Let's send that to 0. Inverse tangent of 0 over here, that goes to 0 as well. Okay. And if a goes to negative infinity, the inverse tangent of negative infinity would be, and remember we have a minus sign right out in front of that, so the inverse tangent of negative infinity, if you remember the inverse tangent graph, you remember that the inverse tangent as a approaches negative infinity approaches negative pi over 2. Okay? And then likewise over here, we know that as b approaches infinity, that upper horizontal asymptote of the inverse tangent function is pi over 2. And so we have pi over 2 plus pi over 2, which is 2 pi over 2, or just pi. Okay, that's it.